Basic economics. The elasticity of demand. The price elasticity of demand and its determinants. Have you ever thought about how price changes affect what people buy?
Yeah, I've heard about price elasticity of demand. What exactly does that mean?
It measures how much the quantity demanded of a good responds to a change in its price.
So, what makes demand elastic or inelastic?
Good question. Necessities tend to have inelastic demand, while luxuries have elastic demand.
Can you give me an example of that?
Sure, if the price of a doctor's visit goes up, people won't stop going altogether, but they might go less often. That's inelastic demand.
And what about luxuries?
When sailboat prices rise, the quantity demanded drops significantly because people see them as luxuries.
What about substitutes? How do they affect demand elasticity?
Goods with close substitutes tend to have more elastic demand. For instance, if butter prices rise, people can easily switch to margarine.
That makes sense. What about the definition of the market?
Exactly. Narrowly defined markets tend to have more elastic demand because it's easier to find substitutes.
So, ice cream has more elastic demand than food overall?
Yes, ice cream is a narrow category, so it has more substitutes compared to the broad category of food.
And how does time factor into this?
Over time, demand tends to become more elastic. For instance, when gas prices rise, people may initially buy less, but will eventually switch to fuel-efficient cars or public transport. Computing the price elasticity of demand. Let's dive into price elasticity of demand, a key concept in economics.
Sounds great. How exactly is it measured?
It's calculated as the percentage change in quantity demanded divided by the percentage change in price.
Can you give me an example?
Sure, if a 10% increase in the price of an ice cream cone leads to a 20% drop in quantity demanded, we compute the elasticity as 2.
So, that means the demand is quite responsive to price changes?
Exactly. A price elasticity of 2 indicates that the quantity demanded changes proportionally more than the price change.
And why do we report it as a positive number?
Good question. Since quantity demanded and price move in opposite directions, we often drop the minus sign for clarity.
That makes sense. So a larger elasticity means greater responsiveness?
Exactly. The larger the elasticity, the more sensitive quantity demanded is to price changes. The midpoint method. So, have you ever noticed how the price elasticity of demand can seem different depending on the direction of change?
Yes, it can be confusing. I saw an example where going from one point to another gave different elasticities.
Exactly. For instance, if we look at 2 points, one at a price of $4 and the other at $6, the elasticity changes depending on the direction.
Right. From $4 to $6, the price rises by 50% and quantity falls by 33%. But going back, it's the opposite.
That's correct. And that's where the midpoint method comes in handy. It helps avoid that inconsistency.
How does that work exactly?
The midpoint method calculates percentage changes, using the midpoint between the initial and final levels. For example, the midpoint between $4 and $6 is $5.
So, a rise from $4 to $6 would be a 40% increase, right?
Exactly. And going the other way, from $6 to $4 is also a 40% decrease. It gives a consistent elasticity of 1 in both directions. We can express the midpoint method with the following formula for the price elasticity of demand between 2 points, denoted Q1, P1, and Q2, P2. The variety of demand curves. The following figures show 5 cases. In this case, regardless of the price, the quantity demanded stays the same. As the elasticity rises, the demand curve gets flatter and flatter. At the opposite extreme, demand is perfectly elastic. This occurs as the price elasticity of demand approaches infinity, and the demand curve becomes horizontal. Total revenue and the price elasticity of demand.
So, when we talk about total revenue, we're looking at the total amount paid by buyers and received by sellers, right?
Exactly. It's calculated as price times quantity sold, or P times Q.
Got it. So if the price is $4 and the quantity sold is 100, total revenue would be $400?
That's right. And we can visualize this using a box under the demand curve where the height is P and the width is Q.
Interesting. How does total revenue change when we move along the demand curve?
It depends on the price elasticity of demand. If demand is elastic, an increase in price reduces total revenue.
Can you give me an example of that?
Sure. If the price increases from $4 to $5, and quantity demanded falls from 50 to 20, total revenue reduces from $200 to $100.
Wow, so the elasticity really affects total revenue.
Exactly. When demand is inelastic, raising prices increases total revenue, while elastic demand does the opposite.
And what about unit elastic demand?
Great question. In that case, a change in price doesn't affect total revenue at all. Other demand elasticities. So, in addition to price elasticity, there are other important demand elasticities to understand, like income elasticity of demand.
What exactly is income elasticity of demand?
Income elasticity measures how the quantity demanded changes as consumer income changes. It's the percentage change in quantity demanded divided by the percentage change in income.
Oh, I see. So, how does that relate to normal and inferior goods?
Great question. Most goods are normal goods, meaning that higher income raises the quantity demanded, resulting in positive income elasticities.
And what about inferior goods?
Inferior goods are different. Higher income actually lowers the quantity demanded, leading to negative income elasticities.
That makes sense. Are there different elasticities among normal goods?
Yes, indeed. Necessities like food have small income elasticities because people buy them regardless of income, while luxuries like caviar have large elasticities, since people can forego them if their income is low.
Interesting. What about cross-price elasticity of demand?
Cross-price elasticity measures how the quantity demanded of one good changes as the price of another good changes. It's calculated as the percentage change in quantity demanded of one good, divided by the percentage change in the price of another.
Are there examples of substitutes and complements?
Absolutely. Substitutes, like hamburgers and hot dogs, have a positive cross-price elasticity, since an increase in hot dog prices leads to more hamburgers being demanded.
And what about complements?
Complements, such as computers and software, have a negative cross-price elasticity. If the price of computers goes up, the quantity of software demanded typically goes down.